Right. Hi, Putala.
I don't.
Right. Sibabuta, very good evening to you. Tasmidua, good evening. Manuladu left, no? So we'll wait 1 minute. Right. So until that, what we were talking about, Putala? Last week, what we were talking about?
We were talking about number systems.
Number system, very good. Tasmidua, can you remember? You're talking about the number systems, right? Manuladu, can you remember?
Yes, sir.
Yeah. So we talk about two number systems. So tell me, what are those two number systems we are talking about?
Binary number system
And
decimal number system.
decimal number system. Very good. Right. So we were talking about binary number system and decimal number system. Right. So apart from binary number system and decimal number systems, Putala, we got another two most popular number systems. That is octal number system and the hexadecimal number system. Right. So quickly we'll refresh our knowledge. Why we need sort of what you mean by number system basically? So it's a basically
that used to represent number systems.
very
Which
good,
is
Putha. It's a
number.
yeah, yes, it's a method, right? It's a method that can be used to represent numbers, right? So we need numbers to do our day-to-day calculations, right? Day-to-day activities. So number system is a method where we can use to represent numbers, right? So why binary number system is so important? I put all the binary number system is so important for us when we talk about computers, right?
Because the computer can't understand our language and they are no only binary.
Exactly, right? Computers can understand only binary numbers, right? It won't understand our human language. So any form of input, we need to convert into the binary number system, which your CPU, otherwise processor, can understand that language, only that language, zeros and ones, right? So what's our most familiar number system? What's a human familiar number system? What's our standard number system, Putala?
Decimal number system.
Decimal number system, right? It's very easy for you all, right? If I say 15 plus 25, you easily you can by memory also you can, right? Tell the answer. But when it comes to binary number systems, it's not so easy. We have some methodologies to convert that into binary number systems, right? Okay. Now you said, Kashmir, you said, so computer cannot understand human language. So we need to give sort of any sort of input. As example, keyboard input or mouse input or video, image, audio, whatever, right? Our voice, maybe our images through webcam, right? Anything. So we need to convert into the computer understandable language. Otherwise, that's binary number system, right? So as example, so we need to send letter A to the computer. right? So computer or the CPU, let's say CPU here, doesn't understand letter A. That's human understandable language, right? Letter A is human understandable character, right? Computer doesn't understand that. So there's a there's a device called keyboard, right? Where you can find letter A somewhere here, right? So this keyboard is connected to the system unit. Otherwise, anyway, CPU is inside the system unit, right? We were talking about that. So this keyboard is connected to the system unit, right? Later on, we'll see how connectivity is happening, right? So that's not Manuladua, I think you're getting interrupted, right? So is it okay now? Manuladua, what I had the Mava?
Oh, sir.
Hari, drop pen on the connection.
Oh, sir.
Now is it okay?
Yes, sir.
Okay, fine. Right. So we were talking about giving input to the computer, right? So as an example, so computer can understand to the only binary number system, right? So when you press A belongs to human language. Ape language A. So we need to convert this key press. Key press that's key press A to something like computer understandable something, right? So where A is located, basically in the keyboard, right? Keyboard, you can find character A, right? Keyboard is connected to the system unit or the motherboard, and CPU is located in the motherboard, right? Okay. Now, when you press A, what will happen, right? This signal, there's a special circuit here in the keyboard, in the back side of the keyboard, right? Or the inside the keyboard, right? So it can detect this key press, right? It can recognize this key press, and it can convert that to computer understandable language like this. So this is example, right? And it will send to the CPU. Now CPU can nicely understand this language, right? Similarly, right? Your microphone, right? This microphone. So you can input voice here, right? So what will happen? There's a special add-on card, otherwise sound card, where microphone is connected. So that's how we connect microphone to the computer, right? There's a special circuit board called sound card, right? So in sound card, we can find several positions to insert the mic or the headphones or something like that, right? Related to sound equipment. So mic is connected to the computer via sound card. So this voice, right, can be converted here to ones and zeros. So keep on converting. Then CPU can understand that language. So this is very common scenario, Pute. If you take any input device, right? That device, the purpose of that device is to convert that particular input to the computer understandable language. Even if you take mouse, right? What's the input we can give through mouse, Putala? So tell me a few inputs we can give through mouse. මොනවද අපිට mouse එකෙන් දෙන්න පුළුවන් inputs පුතේ? Simply click, double click, right? Scroll, or we can move, we can drag and drop, right? So this kind of few inputs we can manage, right? So so that signal will be converted into ones and zeros here. So accordingly, cursor will be right position, or the cursor activities happen, right? So here inside the mouse, there's a special circuit to identify the movement or the click, and it will send it to the CPU. See, if you take any device, any input device, remember that purpose of that device is to convert that particular input, maybe key press, maybe sound, maybe image. If you take even webcam, same thing, right? It will convert that signal into computer understandable language, right? So the other way around, not the other way around, can output devices now, right? So tell me two output devices.
Speaker,
All right, good. Speaker. Okay, that's enough, right? Speaker. Now, speaker won't understand again ones and zeros, right? What will happen? Right? Computer will, CPU will process the data, right? And it will convert back to the, that signal will be converted to the analog signal here, right? So computer output is always digital, that contains ones and zeros, and here there's a special circuit to convert back to the sound. So this ones and zeros will be converted back to the sound here or somewhere in the sound card itself, right? Let's say sound card, right? For the moment, let's say sound card. So this speaker is connected to the sound card. So the output here, the processed output, CPU output, always, right? It comes in the form of binary numbers, and in here it will convert into the analog signal, right? And here speaker will convert that into the voice. See, very easy, right? Don't think too much. So basically you have to understand, if you take any input device, it will convert that particular input into the digital form, otherwise the binary form, and output devices, right? It will convert back to the according to that output signal. If it's voice, voice. If it is maybe display, convert this digital signals into the display, or maybe projector. So whatever, right? So it will be convert. Oh, Puta.
So how does printer go into like binary form? I don't know.
Printer. Right. You want to see how printer works, right?
Yes.
Right. So let me explain that. Now you understand this, right? Sebaputa, you
Yes, sir.
understand this, right? So up to
Yes.
here it's clear, right? Okay.
Yes.
So it's a good question, right? So let's identify, let's see how printer draws an image, right? Right. Let's say this is an image file, right? So we have here, we need to print something like this. Right? Some sort of rectangle, fully black color, let's say as an example, right? So this entire black colored rectangle, Putala, if you zoom it out, right? It consists of so many ink dots. So millions of ink dots. So let me So this one, so let me represent that here, right? So many ink dots, very close to each other, right? So that's how this image is formed. පුතාට ඒක තේරුණාද? Right? පුතේ, ඔය එක image එකක් ගත්තොත් so many single colored dots. Even the TV screen is same. Right? Even if you see the picture in the TV screen, right, it consists of very tiny light bulbs. Let's say those are like LED bulbs, right? Very tiny LED bulbs, very close to each other, right? So what will happen, Putala? So if I want to print this, right, CPU sends signal to the printer, otherwise computer sends the printing signal to the computer. Let's say here, right? So CPU sends the signal in the form of ones and zeros. It cannot do anything else. So what printer does, it will convert this into a specific language, right? Accordingly, ink will flow onto the paper. You know, printer head, there's a special thing called printer head, like this pen, right? So, let me say. So, there's a tip here, right? Only this tip can write here, right? Accordingly, inside the printer, there is a small head where only it can eject ink according to these instructions, right? Printer can understand this information and accordingly it will send the dots here, ink dots, right? So, right, then after injecting all these ink dots here, right? So it will visible as black colored rectangle. You got the point?
Yes, sir.
Right. So it needs to convert that rectangle. So we want to print rectangle. That's our requirement, right? So what processor does? Processor will convert that rectangle into ones and zeros, and it will send the signal to the printer, right? There's a special program runs inside the printer. It's called printing languages also, right? So that's too much for you, right? Just understanding, you think that computer is sending this kind of signals and printer can understand this, and accordingly it will eject the inks. So if here it will, if the printer gets 1, it will put 1 dot as an example, right? If you get 0, no dot. So here again 1 dot, right? Here 0, no dot, 1 dot. So 1 ink dot, no dots, no dots, no dots. So likewise, see, with the form, right? With this formation, right? It can convert into the ink flow. Same way. Got the point?
Yes, sir.
Right. Excellent. Right. So if you want, so curious, get the help of your mother or father. Go to YouTube and say how printer works. So they will explain a little bit in advanced mode, but now you know the concept, right? So you can understand. So you have to see. Otherwise, next day, just remember me, I will find out some video. So easily you will be able to understand the concept. So I will show you a video. So they will graphically show you how the things are happening, right? Maybe in between our class also, if I get time, I will find and I will share it for you, right? So this is the concept, Putala. Not only for the printer. Even if you want to send this signal to the monitor, same thing happens. So monitor consists of so much of tiny LEDs, right? So using that, we can draw images in the screen, or we can draw visuals in the screen, right? If you want to display A, this A consists of so many tiny dots, right? So if you can put so much of dots, right, in any, if you take any area, right? So let's take 1 inch, 1 square inch. So 1 inch here, 1 inch here, right? If you can put, let's say 500 dots here, so that's called 500 dpi. Dots per inch, right? 1 second. Right, sorry, right? So here, within this area, if you can put 500 dots, that's called 500 dpi putala, right? So clarity is not so good. So what if we can put 5,000? So clarity will be very sharp. That's how your 4K displays, HD displays happen, right? Earlier displays, it got very few dots per inch. To take a small square, right? Earlier displays, it got very few dots. Nowadays, we got, right, 4K displays, 8K displays, right, full HD. That's how those displays they invented, right? Scientists invented so much of very clarity displays, putala, high quality displays. So what they do, so thanks to the technology, they can insert more LEDs inside this very tiny place. So you want to make that LEDs very smaller, right? So then 500 makes 5,000, becomes 5,000 now here. So maybe more than that. So that's how your TV screen forms. That's why it's so clear, right? So higher the dots per inch you get the high clarity display. So that's same as printer, right? So if you want very high quality printer, you need, the printer should be able to print so much of dots, right? The printer should be capable of handling so much of dots in that particular area, right? So that's how good printers form. Got it? That's a sort of additional information, but that's very good question. I really like that, right? දැන් අනිත් පුතාලාට මේක තේරෙනවා නේද පුතේ? මනුලදුව දැන් CPU එක print rate යවනවා නම් signal එක, right? මේ අපිට මේ කොටුව print කරන්න ඕන නම් computer දන්නේ zeros and ones විතරයි. So it will send zeros and ones to the printer, and what will happen inside the printer? Printer processor will convert this into as a දැනට පුතාලා ඉගෙන ගන්න මේක into මේ ink dots වලට මේ ones and zeros convert කරනවා කියලා ඉදා ගන්න. So it can form a rectangle or the image, whatever image you want to draw. So it will place the dots according to the bit pattern or this binary digit pattern. හරිද පුතාලා? ඔන්නෝම තමයි output එකක් එන්නේ, right? දැන් අපේ පුතා වුණ print එක ආරයක්. ඒක තමයි example එක. Even for the screen that same, right? Dots per inch මේ dot කීයක් අඟලක් ඇතුලේ තියන්න පුළුවන්ද කියලා දන්නවනම් අනේ dot per inch කියන standard එකේ අඩුයි නම් පුතේ අපේ අපි කියනවා it's not so good quality, not in good quality, but if it is very high, we say it's very good quality, print out the display. අන්නේමයි ඔක එන්නේ. හරි? ඉස්සරහට පුතාලට ඔවා තියෙනවා, right? So we'll see, right, at that time. So shall we move into the number system?
Okay.
Right. right? So any form of input, we need to convert into the binary patterns, right? So number system we explained. So let's see what we got binary number system. We got to study binary and decimal. So binary represents base 2, decimal represents base 10. Usually we don't say, if you take, let's say 56, so we don't say the base, that because that's our standard, right? But let's say we want to represent this number in octal format, that's base 8, right? So we need to represent this 56 as 56 to the base of 8, right? Base 8. මෙන්න මේ විදිහට base එක දාන්න ඕනේ. So even see, so if to see this example, right? So if simply say 111, right? If you don't say anything, if you don't put base here, what will happen, Putala? People will understand this as what? රශ්මිදුව අපි නිකම්ම බේස් එකක් නැතුව මෙහෙම දැම්මොත් මොකද වෙන්නේ? තිබා පුතා? So that represents what?
Base 10.
Base 10. That means in general that's 111, right? මෙහෙම තිබ්බොත් 111. So if you say like this, that's simply 100. If you don't put base, simply people will understand this as 100, otherwise 111, right? So if you want to represent this in binary form, we need to put the base here, right? So basically base represents the numbers are belongs to which number system, right? This base 2 represents, basically the base represents the numbers belongs into which number system. So here we can understand we are talking about base 2, right? Last time I showed you, right? Is this possible, Putala? Is this possible? Manuladuwa? 1, 2, 1 into the base 2. Is this possible?
No, sir.
Very good. Why is that? Base 2 only
Ones and zeros.
ones and zeros, right? So if you say 2, this is not possible, right? So this can't exist. Hibaputa, is it clear? Tashmidwa?
Yes.
1, 2, 1. Base 2, that's not possible, right? Because 2 does not belongs to base 2, right? Tashmidwa, is it clear for you? What happened to Tashmidwa? Right. Hibaputa,
Yes.
you
sir.
got this point?
Yes. sir.
1, 2, 1 cannot exist in the base 2, right? Why? Because 2 does not belongs to base 2. Only base 2 can have 2 numbers. Binary can have only zeros and ones. What happened to Tashmidu? So base 10, so what are the symbols in base 10? Manula dua.
0, 1, 2, 3, 4,
1, 2, 3, 4.
5, 6,
0 to 9 numbers.
Very good, Puta. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So basically, base 2 contains 2 numbers. Base 10 contains 10 numbers. Right? Now, let's say octal. That's base 8. Right? So,
0 to
0 to 7.
0 to 7, very good. 8 cannot exist, right? 1, 2, 3, 4, 5, 6, 7. That's all. And hexadecimal. Hexa means 6. Decimal is 10. So it goes up to 16. 0 to
9, A to F.
all right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Right? Total 16 numbers. Right? But
It should be A, B, C.
yes. I'm coming to that, Putala. Right, very good. So basically, Putala, in hexadecimal, we don't represent 9. So instead 9, we say A. Likewise, for 10, it's B, 11, it's C, 12, D, E, sorry, here, 10 is A, right? So I did mistake. Up to 9, it represents same, right? 10, 11, 12, 13, 14, 15, right? After 9, so we don't use this format. Instead that, for 10, we say A, 11 it's B, 12 it's C, 13 it's D, here E, for 15 it's F. So that's how hexadecimal number system. So remember this, right? So till 9, it goes with the decimal number system, and the next rest actually start from A to F. So that's how hexadecimal number system formed, right? Right. So those are the basics, Putala. So in grade 8, we need to learn only binary and decimal. But you should know these things. Basically, you should know what's binary number system, what's decimal, what's octal, and what's hexadecimal, and what are the symbols associated for each and every base, right? For each and every number system, right? And the base. So they might ask you, what's the base of octal number system? So they will give two, 3 answers: 16, 2, 8, maybe 10. So likewise. So they will ask, what's the base of octal number system? So like in that case, you have to underline this answer, right? 8. So that kind of question. So don't worry about these things, right? So we'll discuss the papers later, right? Right. So these are the symbols and the base and the usually the definition of number system, right? Right. So let's move into the දැන් පුතාලට ටිකක් මතක ඇතිනේ. So that's enough for theory part නේද? අපි ගණන් ටිකක් හදමු දැන්. So can you remember how we solve? So in grade 8, we got only binary and decimal. Here, we need to convert binary to decimal, and we should know how to convert back decimal to binary, right? So you can have notes like this, right? So you can have small notes with me. So these are the things, right? So you can simply put, right? If you want me to give notes, so I can give, but same thing is in the book itself. So anyway, right? We'll see. If you want notes to write, you can understand these things, right?
Yes, sir.
So that's right. That's good. So anyway, I will give whenever it's important. I will give. Otherwise, you have to go through the books, right? Right, here binary and decimal, right? Only this thing for grade 8, these two. Right, octal and hexadecimal, you have another 2 years time. So this comes in grade 10. Even grade 9, no conversions, right? Right. So let's move into the conversion part, right? Even last week we discussed so many things, no, right? Regarding the number system. So today we'll move into the conversion little bit. So now you have to write, right? So you have to solve these equations, conversions, right? First, I will show you few examples, right? So binary to decimal, decimal to binary. So that's all, right? First, we'll convert decimal numbers, decimal to binary, right? Convert decimal to binary. So how to do that one? Can you remember? Last time we did few examples also. So I want to convert decimal equivalent 8 to binary. Manula, can you remember what we did?
We divided
Yes. 8 by
2.
2, right? So if you want to convert decimal to binary, that's base 2. Remember this 2, you need to divide by 2, right? Now, here. So because we want to convert into binary, that's why we divide into 2, right? That's the base, right? So here, we'll divide 8 by 2 here, 4, 0. What's the remainder? 0, right? 8 exactly divided by 2. The quotient is 4 and remainder 0, right? The balance part is 0. Here, 4 divided by 2, 2, it's exactly divided likewise, right? So we need to perform successive division until you arrive 0, 0 or 1, right? Here, 2 divided by 2, 1, and remainder 0. So now we arrived 1 here. No need to perform further division. So until you get 0 or 1. Right? How to get 0? Basically, you need to do again division here, Putala. Then only you get 0, right? Amataka wela digatama bedagana giyot, you will get the 0, right? Remainder as 1. But here, remember, if you get 1, that's enough, right? So no need to divide 1 by 2 again, right? So if you want, I can do it like this. Divide by 2, it's 0, and 1 comes here, right? So I suggest you to stop here, Putala. That's enough, right? Now, you need to write from the bottom to top. Only the remainder, right? What's the first remainder? 1, 0, 0, 0, 0, 0, 0. And remember, if you don't put base, what will happen? This will represent
1000.
1000. 1000, very good. Right? So you have to remember that. That's a must. Right? You have to put base 2. Right? Very simple. Very simple. But remember, this is so important. Otherwise, this will represent the decimal number, decimal form. That's wrong, right? So I will take one more example, right? I'll take one example. One more example, right? We'll take small one. 34. Now, 34, if we simply say 34, that belongs to decimal number system. So we need to convert 34 into binary, that's base 2. So we need to divide by 2. So perform successive division here. Right. 34 exactly divided by 2, that's 17. No balance, that's remainder is 0. Right. Now, 17 divided by 2, it's 8. 2 into 8, 16. We got 1 as a remainder, right? And here 8 divided by 2, that's 4, balance is 0. Divide by 2, 2, balance is 0. Divide by 2, 1, balance is 0. So what's the answer here? Start from the bottom corner, right? So it goes this way. 1 0 0 0 1 0 0 0 0 1 0. Double check your answer. Sometimes because of this, right? So complicated, no? Ones and zeros only. So you have to be very careful, right, Putala? You cross check the number, right? 1 3 zeros, 1 2 3 zeros, 1 and 0. That's right. And remember to put base 2. So that's the answer. Right? Write down these things. So with me, write down these things, right? Now the third example, 49 divided by 2. That's 24. 24 into 2, 48. 1 is the balance, that's remainder. 2 here. 12 into 2, 24. 0. 12 බෙදන්න 2 12 බෙදුවම 6යි ඉතුරු 0යි 2 divided 6 divided by 2 that's 3 0 1 and remainder 1 3 divided by 2 2 into 1 2 and balance is 1 right. So what's the answer from here? 1 1 0 0 0 1 the base 2. Very easy. You will get so many questions. Just simply divide by 2. But make sure you perform the correct division. Sometimes you will get mistake. You will do mistakes, right? Division mistakes you can do. So entire equation, I mean, entire problem will be will become an issue, right? So if you don't perform very successive division, if you don't do the division correctly, your answer might get wrong, right? So you have another way. So you have to convert other way also. So convert into decimal. If you are very good in mathematics, so you can quickly convert this into binary and see whether the question is, I mean, you got the correct answer, right? So this is how you convert decimal numbers to binary numbers.
No, sir.
Right, write down Tuta. Write down these three properly, right? Just tell me when you are done, right? Lakshmi Dura, are you back?
What, sir?
All right, I was talking to you, you are not there, right? So I was wondering what happened to you. Right. Muta, you got this one, clear? How to convert decimal to binary?
Yes, sir.
Right. Write down these 3 examples, okay?
Okay, sir.
So finish, all of you? Finish?
Last one, sir.
Okay, okay, do it. No problem.
Finish, sir.
Okay. Others?
Finish, sir.
Okay, good.
Finish.
Right. Hey, Baputa, in grade 9, I don't have the book with me right at the moment. So you get that, you asked me that printing thing, no? How pixels are displayed, projected into the screen. Those kind of things you can learn in grade 9, no? So before that, as I said, try to, right, learn yourself, right, by yourself. Just with your parents' help, try to see how the things are happening. That's good question, right? Anyway, right. Let's move into the other conversions. Other conversion instance, we got only one conversion. So what is that? Binary to decimal, other way around. So how to convert? So for the moment, we'll keep these three answers, right? So I will erase this one. 49 equals 110001. 110001. That's 2. 8 equals 1000. So 34 equals 100010. Right? 2. Sometimes they will put the decimal symbol also, right? Initially in grade 10. That's also not a problem, right? Even if you say, even if you don't say, that's it. So we got three answers here. We'll keep it for later use, right? Now, let's revise our counting frame. Chuti kalekale counting frame, right? So we'll draw a counting frame, right? So we got beats. We can fill this counting frame using beats, right? So here, ones position, here, tens position, here, hundreds position. So 1, that's anyway 1, right? 10 can represent as 10 into 1. Here, we can represent 10 into 10, right? So if you want to put 134 to the counting frame, right? Right? We got 4 ones, 3 tens, 1 here, 4. Here we got 3 tens. Here we got 100. This is hundreds place now, right? This is hundreds place. This is tens place. This is ones place, right? So for ones place, we need to put 4 beats. 1, 2, 3, 4. Here 3. Here hundreds place it's 1. So how this 134 formed here, Putala? So we got 4 beats, no? Position value is 1, so 4 beats. Here it represents 4 into 1, 4 times. That's 4. Here this represents, right, 3 numbers into tens place. That is 30. Here this represents 1 into hundreds place. So that's 100. So add all 3 together. Here 4, 3, 1. So this is how to expand, how to represent 134 in the counting frame, right? You need to segregate into ones, tens, and hundreds. Even if you get thousands, let's say 100, 1256, you need to put, you have to segregate ones place, tens place, hundreds place, here thousands place, right? Draw the 4-line counting frame. Here you ones place, tens place, hundreds place, thousands place. Right here, 6 beats here. 1, 2, 3, 4, 5, 6. And here 5 tens. Here 200s. Here 1 1000, right? 1 bit here, right? So 6 into 1 here, 1, 2, 3, 4, 5 into 10 here, 2 into 100 here, 1 into 1000. So add all these numbers: 6, 50, 100, 200, yes, 1000, 1256. See? So how to represent this 1256 in the counting frame? So you have to segregate according to the places, right? So we'll give weightages, right? Here, Putala. So one's place, right? So we represent one's place as 10 to the power 0. So last time also I said that, right? 0th power of any number is what? ඕනම number එක 0th power එක මොකද්ද පුතේ? මනුලදුව? What happened to you all? තිබා පුතා බලාගෙන නේද හිටියේ? Did you see this? No answer from you all. Rashmiduwa?
2.
තිබා පුතා? Did you see this?
The answer is 2.
Manulyaduwa? Where are you? So no help from you guys. Ko මට help එකක් නැහැනේ පුතාලගේ.
Sir, is the answer 2?
No, 0th power puta. Right, did you get this one? Did you get this one? So can you help me to put 134 into the counting frame? So this 4 represents ones place here, tens place, and this one represents hundreds place, no? So here we need to put 4 bits for first ones place, and tens place we need to put 3 bits, and hundreds place we need to put 1. Harineda puta. Right? Then we need to calculate. So how many hundreds? We got 1. That's 100. How many tens? We got 3. 3 into 10, 30. How many fours? 4 into, how many ones? 4 ones. That's 4. Add all together, comes 134. Right? Is it clear now?
Yes, sir.
Right. So we need to give weightages here. Right? These positions. Right? So what 1 represents as 10 to the power 0. So if you take any number, 0th power, that is 1. Last time also I said this same thing, neither. For any number, 0th power output, that's 1. Right? So 1 represents 10 to the power 0. Right? This is anyway, this is decimal number form. In api 10 තමයි ඔක්කොම ගන්න. 10 to the power 0. Here, how many tens? 1. So 10 into 1. 1, right? Here, 10 into 10. So that we represent 10 into 10 as 10 to the power 2. So basically, පුතාලා මේ කියන්නේ 10 into 10. So here 10 into 1. Here 10, not 10 into 1, this is 10. Only 1 10. Right? Here 10 into 10. Right? This is 1. So we need to give the weightages. ඔන්න මතක තියාගන්න. So I will erase this. Right? We need to give weightages. Right. So what we are doing now? Converting decimal binary to decimal, right? So take one binary number. You need to understand this logic, right? Right. Okay, I'll erase this. Anna Putala, take this example. Now we have binary number 1000, right? So we need to convert that into the decimal number, right? Here we have to write 0th position, right? 0 into 2 to the power 0. This position 2 to the power 1. 0 into how many zeros? What's the value? 0 into 2 to the power 1. Here 0 into 2 to the power 2. Right? Increase the position. Weight you have to increase. Right? Position value is increasing. Right? 1 into here 1 into 2 to the power 3. See? 0. Just similar to your counting frame. This is the 0th value, this is the first value, this is second value, this is third value, likewise. If you put it in 10, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. Right? Similarly, you can put it in binary form as well. Right? So this represents the weightage, position value, right? Right. See here. Now, calculate this. Manuladu, help me to calculate 0 into anything?
0.
0. 0 into anything? Again?
0.
0. 0 into anything? 0.
0.
1 into 2 to the power 3. What do you mean by 2 to the power 3? 2 into?
2 into
2 into 2 into 2. Very good. Dekeva tunai. 2 into 2 into 2. That represents 2 to the power 3. 2 into 2, 4. 4 into 2, 8. So this represents 8. 8 into 1?
8.
8. Add all together. That's
8.
8. See? Now our answer is correct. See? We converted this number to binary. So we got binary here. So this our calculation is right. See, we got 8 in base 10. So our calculation is right. So we are so happy now. Let's move into this one.
Teacher,
Now you help me.
sir,
Yeah, Puta.
is there a base? How can you put the base, sir?
I didn't get your question, Puta.
Like in there, there's a 8, the base, the 10.
Base. What does it mean? If you don't put any base, that belongs to
8.
decimal, no? Right. You can put, always you can practice here. Put the base 10. So that's good practice. But if you don't say base, so that means decimal. That's our natural number system, no? So we have a small exception. So anyway, so we'll write this one, 10, base 10. So we are converting binary into decimal. So this is the way to calculate, right? Take this. Right. 11001. 11001 base 2. So what's the answer we should get once we converted this one? So once we convert this decimal
49.
binary number, yes, we should get 49 as an answer. 49 enno convert karam. So if 49 equals 110001 in base 2, if we convert back, we should get 49. Base 10. Right? we should get ඔක්කොමලා පුතාලාට තේරුණාද? Reba puta, it's clear? Manladu, it's clear, no? Kashmindu?
Yes, sir.
Yes, sir.
Okay. Right. So you should get, so both ways. You can convert 49 into this one. Binary, you should get this one. If you convert back, you should get 49. Right. Let's see. Start from here. 1 into 2 to the power. Let's start from 2 to the power 0. Right. Here. 0 into 2 to the power 1. See, if you feel lazy to type, put these things first. 0 into 1 into, so 1 into. Make sure, double check it. 1 came here, 0 came here, 0 came here, 1 came here, 1 came here. Right. Now put the weightages. 0, 1, 2, 3, 4. Now write the value. 0, 1, 2, 3, 4. So that way you won't miss anything. 0 in the patangana, 4 tenaka. Remember, you start from the 0, right? Topmost value, that's 0. Come down, right? Right. 1 into 2 to the power 0 is what?
2.
0th value of any number, that's
0.
Wow,
1.
1. 0th power of any value, that's 1. So here, 2 to the power 0, any value, that's
1.
here, 1. 1 into 1, that's 1.
1.
Right, okay, good. Here, 0 into anything, apita kamak na make a mono 0 into anything, that is 0. Again, 0 into anything, that's 0. 1 into 2 to the power 3. Now, 2 to the power, what is 2 to the power 3? 2 into 2 into 2.
8.
That's 8.
8.
So 1 into 8. 8. Here, 2 to the power 4. 2 into 2 into 2 into 2. That's 2 into 2, 4. 4 into 2, 8. 8 into 2. 8 into 2.
16.
16. Yes, very good. 16. 2 into 2, 4. 4 into 2, 8. 8 into 2, 16. I put 16 here. I think we did something wrong here, right? 49 divided by 2, that is 24 to 12.
Yes. There should be 3 zeros. 1,
Yeah.
1, 0.
1, 1,
0, 0, 0.
0, 0, 0, 1, right?
Yes, sir.
That's what. So that's why I told you, right? See, if you are taking back to the paper, so you have to be very careful. You will miss. So entire answer is different. So here we got another one. Now here 1, 0, 0. This one again 0, and here we got another one. See, thanks for correcting me, right? So I did that mistake, right? Okay, no need this one, right? Now here 1 into 1, 1, 0, 0, 0, 1. That's right. Right. 2 to the power 5. 2 into 2 into 2 into 2 into 2. 2 into 2, 4, 4 into 2, 8, 8 into 3, 2, 16, 16 into 2, 32. No, Puta, you did we did some mistake here. Let's convert this one. This comes another number, right? Let's convert this properly, right? 49 divided by 2, 24. One one triple zero one. That's correct. So let's start from the beginning, right? So we did some small mistake here. Let's convert and see here. 49 divide. So you can see the board, right? Give me 1 second. Right. Let's divide by this one. Right. 24. That's 48. Remainder 1, 2, 12. Remainder 0. Divide by 12. 6. Remainder 0. 2. 3. Remainder 0. 2, 1, 1. So this is correct, right? 1, 1, 0, 0, 0, 1. 1, 1, 0, 0, 0, 1. Right. This is correct. So now convert back to decimal form, right? Right. So 1 into 2 to the power 0, 0 into 2 to the power 1, 0 into 2 to the power 2, 0 into 2 to the power 3, 1 into 2 to the power 4, 1 into 2 to the power 0, 1, 2, 3, 4, 5. That's nothing but right. Come back to this. Right. Now this is correct, right? 1 into 2 to the power. So 1 here, 0 take here, 0 take here, 0 take here, 1 take here, and 1 take here. Start from 2 to the power 0, 2 to the power 0, 2 to the power 1, 2, 3, 4, 5. Right. So help me to solve this question problem, Putala. 2 to the power, any number, 0 power of any number, that's 1. So that's 1, 1 into 1, 1. 0 into anything, that comes 0. Here is 0, 0, and here 0. Here, what's the value? 2 into 2 into 2 into 2. 2 into 2, 4 into 2, 8. 8 into 2, 16. Right. Here, 2 into 2 into 2 into 2 into 2. So what's the value, Putala? 2 into 2, 4. Iba Putal, help me.
32, sir.
Ah. Right, 32, right? Add all together. 6, 7, 8. 9, 3, 4, 49. So we did some mistake here, right? So that's why. So we want to calculate and we want to check the reverse calculation as well. So right now this matters, right? We did something mistake. So Hibaputa, you correct me, right? We missed out this one, and so from the beginning we started. Now we got the answer. So likewise, we convert this one also. 34. First of all, check whether 34 is equal to this one. Putala haduwa neda? 34 equals to this binary number. Is this correct? Shall I erase this?
It's correct.
It's correct, no? Right. Shall I erase this one? Did you write down?
No, sir.
Write down. Put it's better, no? So let me finish this one also. Then all the three you write down, right? So how to do that one? Separate the position. That's not nice, Ned. That's not nice. So 1 0 0 1 0. So I'll write here, right? That's equivalent to 34. So separate the positions now. 3, 4, 5, 6. Right. 0, here 1, here 0, 0, 0, 1. Right. Put the position. Help me. 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Is this correct?
Yes, sir.
It's correct, no? So do the calculation. 0, 2 to the power 1, that's 2. 2 into 1, 2, 0, 0, 0. 2 to the power 5, we found here. So that's 32.
32.
32 into 1, that's 32. 32 plus 2, 1. We did small mistake here, no? That's an appearing shooting mistake. So in that case, you have to match the both. You can find out where the mistake was, no? So correctly, leisurely you divide and see. Put them better harima lazy unata. That kind of shooting mistake. So we'll get the different answer. So I caught that error when I'm reverse calculating. मैं binary एक convert करा दी तो I caught that error that it was wrong somewhere here. So we have written wrong, right? So properly we definitely you will get this kind of question to your O-level exam. Not only one, maybe 2 questions, right? Be careful when you have to very carefully you have to do the calculation, right? Better you practice so many things and do the reverse calculation as well. You convert back to binary as well, right? You convert back to binary to decimal and decimal to binary and binary to decimal as well. Cross-check both the answers, then arrive your answer, right? Right. Putala, this is example 1, this is 2, and this is 3. Write down these 3 also. Manulya do clear the puta?
Yes, sir.
All right. Next day, full of calculation, right? Be ready. Mama board එකේ ලියලා බලන් ඉන්න පුතාලට calculate කරන්න දීලා. So one by one we'll solve and see. අපිට ප්‍රශ්න එන්න පුළුවන් අපි බලමු. So we'll take any number. You suggest me any number and we'll do the conversion and see, right? And we'll do the paper questions as well, right? With this, basically, Putala, your first chapter is over. Tell me when you are finished, okay? Mahesh Puta, what happened to you?
Sir, today only I have maths exam, so it finished at 8:15. That's why I got late, sir.
Oh, really? So I will share this session, right? So just go through. You missed, I think, first 1.5 hours, neither.
Yes,
So
sir.
you go through this. So same thing we were discussing like last day, right? We were discussing about basically we refreshed our knowledge. Basically we discuss about what are the number systems, what are the symbols associated with that number system, and why we need number systems, those kind of simple things. Last week also I explained same thing, right? Then we came into the conversion, that most important part, right? We converted decimal into binary. So we arrived these answers and we converted back binary to decimal, right? So why we need binary number system? Because computer can only understand binary number systems. Otherwise, basically ones and zeros, right? So in the form of any input, right? Irrespective of any type of input, right? Let's say voice, let's say images, let's say text, let's say anything, any form of input, we need to convert into the binary form where CPU can understand. Only it can process ones and zeros, right? So we need to convert. Even if you press A, character A in the keyboard, it converts, right? That keyboard is capable of converting that A into the binary form where CPU can understand the logic, right? Right. If you say like voice, right? Microphone, through the sound card, microphone can understand our vocal. It can convert the sound card. It's located inside the system unit, right? It's attached to the motherboard, right? That sound card is a specially designed circuit where you can convert our vocal signals, right, into the binary form, right, where CPU can understand the voice now, right? Voice will be converted. So if you want to invent anything, right, so your sensor should be able to, newly invented sensor should be able to convert that signal into the digital pulses, otherwise digital signals. That's ones and zeros, basically, right? So that's what we were talking about, right? Just read your book. So it's clearly mentioned, right? Even our Hibabuta asked very good question: how printer can print? Printer prints. So if the computer can understand ones and zeros, how it gives the printout, like in our sensible way, right? So what it does actually, printer takes the digital input, ones and zeros, to the printer, and it will convert. So through the printing mechanism, it can convert the zeros and ones into ink dots. According to the bit pattern, bit stream, it will inject ink. Right? There are special languages, so that's too much for you, right? So print descriptive languages are running inside the printer, right? So that's not required. So basically, you think, right? So printer will get the bit pattern from the CPU, right? And it can inject ink dots to the paper according to that bit pattern. So visually, it can create a graphic. Maheshwata, did you understand the concept?
Yes, sir.
Right. So in computer can work only in binary form, right? So whatever input you give, right, you need to convert into digital binary format. So that's why binary number systems are so important. So these are very basic. So here we learn how to convert simple decimal numbers into the binary form, right? See here. So basically you need to divide this number here. See, I have taken one example, right? Take any number. So if you don't represent the base here, that's actually represent base 10. So we need to divide. If you want to convert binary to decimals, and this binary is base 2. So you need to divide it by 2, right here, and arrive your remainder. Write it from the bottom, right? 1, 1, 0, 0, 0, 1. So 49 equals 1, 1, 0, 0, 0, 1. And base 2. Don't forget to put this base 2. It's very important. Otherwise, what will happen? Others? So if I say like this, Maheshwata, you watch it properly. If I say without base, what will happen?
1000.
This is right, basically. Maheshwata, did you understand? So we usually because of our right native understanding, we say this is 1000. But here basically it represents base 2 binary form. So we need to put this base as well. Otherwise, it will fall into our normal language, normal understanding. So people would say this is 1000. So it's not 1000, it's 1000. Right. Now everyone. So can this exist in base 2? No, because 2 cannot exist in the binary format. Because binary can have only ones and zeros as its symbol. So 2 cannot contain, right? 1 to 1 base 10, yeah, that's possible. 1 to 1 base 8, that's also possible. Because 10 can have from 0 to 9, base 8 can have from 0 to 7, right? So those are the symbols, right? So we were discussing the same thing, Puta. So I quickly refresh, right? So hope you can understand, right? Next day we'll solve few more examples, right? With that, we can finish off our lesson 1. That's great, no? So we have only how many lessons? 6 lessons, no? Sorry, but I lost the connectivity from my end. Am I audible? Anladua?
Yes, sir.
Right, okay. So did you
Yes.
finish this one, Hibaputa?
Yes, sir.
Right. Manuladua, Kashmidua? Maheshwata, if you can quickly, you can write it down. Otherwise, just try it yourself if you can understand,
Okay, sir.
right? So we converted 8, 34 and 49 to the binary form, right? So we got another 2-3 minutes. So I will show you one example. So you write it down like this. Others, look at this, right? So I take 8. So I want to convert base 8, sorry, decimal 8 into the binary form. Divide by 2. 4, remainder 0. It's 2, remainder 0. It's 2. That's 1. You need to perform the successive division until you get 1 or 0. So 1, basically I stopped here because I got 1. So the answer is you have to write it from the bottom, right? The last remainder 1 0 0 0 into the base 2. So that's how it's a quick calculation, right? 8 I converted into base 2, right? Likewise 34. 49 where we stuck near the butal, right? Mahesh Puta, you write down this. Did you get this?
Yes, sir.
Right. You write down, okay? That's one example. Likewise, you try 34 and 49 as well. You should get these two answers. Do the division and check. අපේ අනිත් පුතාලා කරලා බැලුවාද? Right? So this comes to an end of your first lesson, but not end. Next whole day, we'll do the calculations. You help me, right? I don't have any calculated one. So whatever you tell, we'll simply solve and see whether it is correct or not. Because we can't do everything. No, විභාගයට මොකක් වේද අපි දන්නවද? So randomly we'll take some numbers and we'll convert and see. That's very easy, right? So shall we stop for today? මම හිතනවා පුතාලා ඔක්කොටම අද clear ඇති කියලා. කරපු දේවල්. Is it clear, Hiba Puta? Are you okay today?
Yes, sir.
Right, very comfortable, right?
Yes, sir.
Right. Kashmi Dua, you're not talking since long time. So anyway, Manulla Dua,
Yes, sir.
is it clear today? Everything is clear?
Yes, sir.
Right, Manulla Dua. Mahesh Puta.
Yes, sir.
Right. So
Sir.
You might get problems, right? Next day you can log on time, right?
Yes, sir. Today only I had the exam, sir.
Okay, fine. So next time I will again refresh these things and we'll do new calculations. Okay? Right. So let's stop for today, right? So hope to see you next week. Aiban Putala. Right?
God
Right,
bless you.
okay. Have a good day,
Aiban,
right? Good
sir.
night. Aiban.
Good night, sir.
Good night, Puta.
Good night, sir.